I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 1st. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. And finally, we'll get into a healthy discussion about snow over the Sierra and the southwestern United States. Let's get to work. Looking at significant wave heights in the North Pacific Ocean, we see remnants of a gale still producing 21-foot seas off of the South California coast over a pretty broad area, and the bulk of that energy is radiating to the southeast. We also see a gale, kind of a weak one, just south of the eastern Aleutian Islands. It too producing 21-foot seas, but not of any real interest. And a tropical system off the Philippines producing some seas, but of no interest to our immediate area anytime soon. Let's get into it. As usual, we'll start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough like right there. That is a pretty well-defined, clear, almost pinched trough. Anyway, that flow, you can see it right there at the upper levels of the atmosphere, creates like a countercurrent, a counterclockwise flow, and that's the hallmark of low pressure. That also manifests itself down at the surface. Of course, that low pressure generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. And swell, when it hits your beach, turns into surf. So we're very interested in troughs. We have one off the California coast. We know already from the previous chart, there's an area of 21-foot seas out here associated with this trough. So that is of some interest. We also see a kind of a trough trying to organize here over the date line, but there's not a whole lot of good wind energy pushing into it. Notice this trough here has, 130 knot winds pushing down into it. So the stronger the winds pushing down into it, that seems to really help ramp up the counterclockwise flow, and then that, of course, supports all the wind and everything else. This one, what do we have? Maybe 100 knot winds, and even at that, not well organized. So looking at the jet in general, we see it pushing off of Japan, but it's kind of split, two lobes here. Kind of tries to organize over the date line, but then the whole jet ridges north, and a ridging pattern produces high pressure. Also notice a little split here too. It all comes together southwest of Southern California and then roars onshore there. Weather certainly is the norm for the North and Central California coast this evening. Right, let's put this into motion. As we get into Monday morning, the trough starts pinching off of the California coast. Support for gale development fading, and we still have this like a high there, a split jet there. Wind energy building off Japan, but just over the greater Pacific Ocean, not a very cohesive. In fact, look at that, even becoming more split as we get into Tuesday. The low, remnants of the cutoff low off of California, looking to continue, at least at the upper levels. But notice, winds getting very consolidated, pushing strong by Tuesday night off Japan to 190 knots. We're looking for a trough to form from that. Oh, here we go, another trough. Now this is, again, sort of this split flow, not a good amount of energy. 120 knot winds falling into a trough developing in the Gulf on Wednesday. And that trough, again, just like the one before it, off the U.S. West Coast, circulating, looks to be mainly a weather producer. You notice the jet just pushing onshore hard here. Winds off of Japan at the same time building to, 210 knots? That's pretty strong. We really would love to see the jet do that the whole way across the Pacific, at some point dip into a big old trough. Will that happen? That is the nail-biter scenario. Notice the trough here as we get into Friday, pushing into the Pacific Northwest. And energy building off of Japan continuing. Hey, there we go. There's a bit of a trough starting to develop into the, we'll call it the northwestern Gulf of Alaska on Saturday. Wind still very solid, 180 knots, just pushing the whole way from Japan into the Gulf of Alaska. And that trough continues off to the east into Sunday. The jet slowly weakening, but solidly consolidated, and we're at 180 hours out now. So the trough not looking as good, but still some support for gale development there, and maybe more weather into the U.S. West Coast. All right, let's go take a look down at the surface. So here we are, surface level pressure, surface level winds, our low pressure off the California coast. Now this is very weak. What is that, 100 and maybe 1,000 millibars? That's not low at all. If it was like 960 or something, then we'd be talking even 968 millibars, but 1,000, not so much. But you see, here's the counterclockwise flow of that low. We know the trough is doing this sort of thing right here. Okay, that's pushing south winds up into the central and North California coast. High pressure there, a little bit of a low, if you want to call it that, up in the Gulf of Alaska, producing 35-knot winds, not doing much. I mean, we're looking for something more meaningful. And here we go. So get into Monday night. New little gale starts forming, 45-knot winds over the, we'll call it the North Dateline region, falling east-southeast, almost 50-knot winds over a little area there. Also notice another gale developing, all landlocked here over Kamchatka and the Kuril Islands. So this guy is the main focus. He falls southeast, winds fading to 35, almost 40 knots as we get into Wednesday morning, and then doing the same thing like the last gale off the California coast, stalling, rebuilding, 45, almost 50-knot winds there. 50-knot winds, looking pretty solid. Now, the issue here, yes, it is a fairly solid size gale. It has some decent winds, but it's all within, what is that, about 600 or 700 nautical miles of the coast with a healthy fetch of south winds scraping the coast here. Probably pretty much of, whoa, and what was that? 55-knot winds on Thursday midday. Probably pretty much of a mess the whole way down to Point Conception. Whatever swell does get produced, Southern California down into Baja, probably the more likely scenario. And it continues rotating off the coast as another system develops over the North Dateline region on Friday night with 45, quickly fading to like 40-knot winds and a broad area 30 to 35-knot winds behind that by Saturday. The lows pretty much done for California. And look at that. Actually, Saturday evening into Sunday, a light wind pattern, finally. I mean, we'll get into it when we get into the wind model thing for California, but it looks like a pretty miserable week along the coast north of Point Conception. Now, here we go into Sunday. If this holds up, this looks most interesting indeed. A broad area, 35 to 40 to 45 to 50 to 55-knot winds. Now, of course, this is a week out. Don't believe any of it, but it looks interesting. We know the jet is raging back here, and there is a trough in this area, so all this adds up, both at the upper levels of the atmosphere and down at the surface. Let's see what these winds' effects will be on the ocean surface. First off, we're just going to go back a little bit in time to Thursday, Thanksgiving Day. Little low developed in the northwestern Gulf, falling south, producing 34, 35-foot seas. And then it did the same deal. It kind of reorganized off the California coast on Saturday with 33-foot seas. And now, here's where we are right now. That swell is hitting the coast. Nothing super impressive. Let's go look at a buoy real quick. Here's buoy 029. Here we go. We'll do it right. Drag this up right there. Okay, off of Point Reyes, California. Okay, C-dip buoy. We'll just take a look at the energy here. 18, 17. Yeah, nice little ball of like 17-second period energy, and then a bunch of wind swell probably out of the south at about 9 seconds. Generating wave heights supposedly in the 10 to 12-foot range, we'll say. We can actually scan down the table here. Here is the most recent reading. 12 feet at 9.9 seconds. That's all wind swell for sure, and it's coming out of a very southerly direction. You literally look at the coast, and waves are going at a 45-degree angle up the coast. And then 8.8 at 13 seconds, but we also see 7.3 at 15. So that's that more energetic pulse that's coming from the Gulf and the low off the coast. All right, so let's go take a look into the future. This low off of Southern California, yes, there is swell working its way south into Central California and into Southern California and Baja over the next 24 to 36 hours. Problem up in Northern California, it's just going to be a mess. We'll get into that. I'm not even going to belabor that point. Small gale developing up in the Northern Gulf, 26-foot seas. Not paying attention to that either. Here comes the more interesting one on Tuesday developing. We saw this on the surface level pressure charts. 29-foot seas building to 32 feet as we get into Tuesday night. Falling south, this does the exact same thing as the last system. Sideband energy for Hawaii. The focus again is this target right around in here. The low redevelops supposedly on Thursday. I mean, we're into Thursday already with, what is that, 35-foot seas? Yeah, it's pushing it. We'll say 33-foot seas. There we go. Now looking more solid. 39, 37-foot seas. But most of this energy probably targeting, we'll say San Francisco southward down into Baja for sure. And then that moves onshore. Another low moving in across the northwestern Gulf, but small. And then where are we? We're at Sunday now. Broad area fetch, we know, is supposed to be developing back here. Here come the seas from it. You get the little picture of it 180 hours out. Now remember, just because you have wind on the ocean surface doesn't instantly mean you have the seas. It's a 6 to 12 hour ramp up before things really start going. The wind has to blow for a while over the larger area, aimed in your direction, and with sufficient velocity. That's what makes period, and we need period to traverse the distance. It's a good from the date line, what is it, like 2,200 nautical miles into California, not so far into Hawaii, but you get the general picture, and this is a week out. We don't believe any of that, but at least it appears there is hope for some maybe longer period, larger and cleaner, longer distance swell. All right, near shore. We're really, we normally go here and look for wind swell, but this time of year, we're not looking at wind swell. We don't care about that. Just weather conditions along the California coast. It's abysmal right now. You see south winds, 30 knots in the San Francisco area. That was as of 10 o'clock this morning, still continuing, and it was, you couldn't hardly stand on the beach with a surfboard. It was blowing, it was gusting so hard it almost knocked you over. So not a great surf day, and there wasn't hardly any swell, though this afternoon it did start picking up. Anyway, we see the south wind mess just continues, isolated mainly from Point Conception northward. Yeah, maybe some of that into Santa Barbara County, but not too bad. It continues into Monday night. Tuesday, here's the remnant low, still pushing some wind. You can see the barbs. There we go. Into the California coast still. Here comes the next low developing off the coast. Finally, a little break on, was this Wednesday afternoon? By time we get into Thursday morning, south winds start up all over again. Really healthy fetch, relatively close to the coast. You see that south winds just nuking again. Now, the good news is when you see this, that typically means precipitation, but the south winds, without the core of the low moving on, generally means higher snow levels, warmer temperatures, certainly better than the 43 degrees we had in the San Francisco area 2 days ago or a day ago. Much warmer today. 53 to 55 degrees, something like that. Anyway, you get the idea. We're into Friday. South winds still continue. Just a mess into Saturday. Still south winds, but then you get to Sunday before finally weak high pressure sets up. Just probably generally a calm flow, and we're out at 180 hours, but it almost looks like the storm door, this front, is the leading edge of yet another massive weather system moving towards the coast. Now, the good news is these south winds, low pressure, produce rain, produce snow. The bad news is it isn't supposed to let up anytime soon. All right, quick zoom in. You see snow over the Sierra, rain from Point Conception northward, and you just keep your eyes in this area. It just continues the whole way through Monday. Tuesday breaks up a little bit. Wednesday almost looks like it organizes some more and moves into Southern California. I'm going back there just a little bit, starting, Wednesday morning into Southern California. Finally clears out on Thursday, but by Thursday night, here it all starts again in the northern half of California, pushing into central California by Friday. And here comes the snow for the Sierra again, Friday night into Saturday. Pretty heavy, pretty consistent, going on through. Finally, Sunday, things clear up, and we're 180 hours out. So, a wet, windy mess for California, mainly north of Point Conception, but Southern California will not be left out of the rain. A quick look at the snow picture for the southwestern U.S., mainly focused on California. And you can see, just looking at the colors, you get a general sense of where the focus of the snow is into. This is through Monday evening. Things fade out in the Sierra. Another little bit, mainly southern Sierra, as we get into Wednesday. That fades out, heads for Colorado. We have a break, and then here we go on Friday. The next system setting up, just bombing away. When you see oranges and reds in here, that's pretty solid. We'll have to take a look at snow levels and get a sense. And that goes into Sunday morning, and then it clears out. Okay, and that's for the week. Actually, this goes out a little bit longer. So this is a 240-hour GFS model. Don't believe any of this. And then here we go. Oops. Looks like the next system setting up about midweek on Wednesday. 10-day snow forecast. Really, we'll just go for a week out, go to about here. For the Squaw Valley area, so about 34 inches from the first system on top of what has already fallen. And I think at Squaw, as of this morning, there was 25, 26 inches, something like that. So they had some runs open. Things are looking better. But as we get through next weekend's dump, supposedly, then we're looking at about 90-inch total accumulation. That's pretty solid. Snow levels. Here's the bottom of the resort. Here's the top of the resort. Snow levels, 7,000 feet, dropping down for next weekend, lower. And then a bit of a warm-up after that. Wind level. Wind, not too bad. Blowing pretty good by next weekend's storm. Upper Mountain, with 40 to 60 mile an hour winds. Hard to say. Let's go look at another resort. Quick look at Kirkwood. 2 feet expected from the first system, and then throwing another, up to about 66 inches, something like that. So not bad. Snow level, now Kirkwood's a bit higher. So base elevation, 8,000 feet. Snow level, below the base the whole time. Above the base, below the base the whole time. And then that warm-up peak. So things looking pretty good there. Pretty windy, though, as well. 60-knot winds on next weekend's system. So, probably pretty blowy. But the good news from all that is certainly rain, snowfall. We'll take it any way we can get it. It was actually looking pretty bleak there the early part of the fall to be getting this much snow, and not just a single dump, but multiple systems queued up. That's pretty good for this time of the year, especially given that this year looked like it was going to be a La Nina year. So we'll take what we can get, and we will not complain at all. All right, so let's go take a look. Long term, what's going on? MJO, first factor we're very interested in. That's that 3 to 4 week oscillation, moving between an active state. When it's active, it tends to support precipitation, storm production, feeding the jet stream over the North Pacific Ocean, and then the inactive phase, which does the exact opposites, like high pressure, clear blue skies, no precip, and lack of surf. And then, of course, what's going on with El Nino, La Nina? Well, we're going to find out. All right. As usual, we like to look at winds in what we call the Kelvin wave generation area. All right, so what are we looking at here? This is the West Pacific here. This is the East Pacific here. That is the equator, and we're only interested in the equator, and we're only interested in the West Pacific. There's the date line right there, and that little guy right there, that's New Guinea. So the Kelvin wave generation area from 170 west, 5 degrees north and south of the equator, out the whole way to about 135 east. So you draw a box in your mind right there. And what we're interested in is the winds in this area. So this data from the TAAO buoy array, series of buoys strung across the equator used for monitoring El Nino. We see, we're just looking at the arrows. The colors are sea surface temperatures. We see winds out of the east, pretty strong over the East Pacific, fading, trying to come up a little bit out of the date line, but then we see, hey, no trades over here in the Kelvin wave generation area. If anything, it's the reverse of trades. It is westerly winds. That is typically a sign of the active phase of the MJO. When trades are stronger than normal here, that's the inactive phase. When trades are reversed or calm, then that is typically a sign of the active phase of the MJO. And the active phase, that's what we want, because that's what feeds the jet stream, produces storms, and swell, you know the drill. All right, anomalies, differences from normal for this time of year. So it's not just the actual wind speeds. How are because the winds sort of cycle in a known pattern depending on what time of the year you're in. So these winds, yeah, they're strong out of the east, but just looking at these little arrows, that's kind of normal for this time of year in the East Pacific. But in the West Pacific, they're stronger than normal out of the west. Again, another sign of the active phase of the MJO. All right, let's dig deeper into the MJO scenario. What's going to happen over the next week? All right, so this is an interesting chart. Those of you that watch us know the deal on this one. It's the whole planet on one chart with time, okay? And it's only, so this is 850 millibar zonal wind anomalies. Fancy word for what are the winds doing up about 4,700 feet in the atmosphere. And this is only from 5 degrees north to 5 degrees south on the equator. And what we're really interested in is, so the reds and the yellows are westerly anomalies, the blues are easterly anomalies. So let's get ourselves oriented. The Pacific Ocean starts about here and goes to about here on this chart. So you look at that, you go, God, that covers almost 50% of the Earth's surface, which is, it is a large body of water. Kelvin wave generation area is what we're really interested in, and we're interested in the winds over the Kelvin wave generation area. So that's like from here to here. So you just go straight up the chart, draw 2 lines in your eye. This is the Kelvin wave generation area, and you see since early November we've had westerly winds. That was the active phase of the MJO. The active phase was supposed to shut down somewhere in, right before Thanksgiving. Boom, look at this. Big old westerly wind burst. Not super strong, but a solid burst of westerly anomalies. And that's continuing today. Now the forecast has that slowly fading as we get into about December 7th. And easterly anomalies, look at this right here. This is in the Indian Ocean. Very strong. This is like this blocking Indian Ocean dipole type situation. That is supposed to mellow some, but continue, and it looks, just eyeballing this, like the inactive phase of the MJO is supposed to set up, if it hasn't already. But looking at this, you just go, that looks like the active phase of the MJO for sure. Let's dig deeper. Now here's where things get interesting and a little bit contradictory. This is the an MJO model, outgoing long wave radiation. So there's multiple components to the MJO. There's the wind component. There's also the cloud cover component, right? Okay, which you could sort of use to say pressure. So the oranges and reds are larger than normal amounts of sunlight, more sunlight reflectivity off the ocean surface, which one could then interpret to say, well, that's high pressure. That's the inactive phase of the MJO. You're going, how do we have westerly anomalies with the inactive phase of the MJO? Well, we do. We'll just leave it at that for right now. Okay, the forecast. Inactive phase of the MJO continuing for 5 days, 10 days, 15 days. This per the statistic model. Sure looks like the inactive phase of the MJO setting up. The dynamic model suggesting the same thing, but suggesting the inactive phase a bit stronger at 15 days out as compared to the statistic model. Okay, we'll keep that in our mind. Let's keep going. So phase diagram charts, another way for monitoring the MJO. This is, so what are we looking at? Assume this circle, you're looking down from the top on our planet. That's the North Pole right there. The MJO travels around the equator from the Indian Ocean to the Maritime Continent, like Bali in that area, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The active phase goes round and round. Wherever the active phase is, let's say it's here, the inactive phase is typically on the other side of the planet. That's a very, very rough description. All right, the heavy dot is where the active phase is today. So in the Indian Ocean. So this model is saying the active phase is not over the Kelvin wave generation area, even though we have westerly anomalies there. So Okay, we'll take it. Whatever. Westerly anomalies, any way we can get it, feeds the jet stream, we'll take it, but it's not necessarily associated with the active phase of the MJO. All right, the heavy dot is where the active phase is. The further out from the circle it is, the stronger it is. So we'll say it's in the West Indian Ocean, extremely weak, and the forecast has it moving weakly towards the maritime continent, but one of the runs says, well, maybe only to the Indian Ocean. All right, the GEFS model says, yeah, basically same thing, moving through the Indian Ocean over the next 2 weeks, maybe making it to the maritime continent. So no immediate indication of the active phase of the MJO moving into the preferred area, which here is the West Pacific, in the next 2 weeks. 40-day model. All right, so this is a precipitation model up at jet stream level. The greens are areas favorable for precipitation. We'll say roughly equating to the active phase, the MJO. The orange and the reds are areas not favorable for precipitation, dryness. All right, so what's this saying? It looks like we have remnant activity from, we'll call it the active phase of the MJO or something, working its way across the Pacific, moving into Central America and gone by, oh, the end of December. Interesting. And the inactive phase building today in the far West Pacific, making its way across the Pacific and into Central America on January 10th, with the next weak active phase setting up in the West Pacific December 21st. Okay, interesting. Let's keep digging. The CFS model 1 month forecast. All right, so what are we looking at here? Again, this is the whole planet on one chart. Date lines right there. Kelvin wave generation area between that tick mark and about there going up. So here we are today. Here is the active phase of the MJO. That makes sense. This is not the inactive phase for sure. The reds are your westerly anomalies. That's where we are. And this has the active phase moving at the Kelvin wave generation area ends right there. So on about December 8th, the active phase is gone from the Pacific Ocean. The dotted contour is the inactive phase of the MJO. The blues are the easterly anomalies, and the dreaded inactive phase of the MJO moving its way into the Pacific through about at least the Christmas time, through the Kelvin wave generation area, at least through Christmas time. Okay. And then the 3-month CFS model. We don't believe a model a week out, much less 3 months, but this actually the CFS model gives you a pretty good sense of what's going on, at least from a MJO bordering on an El Nino sort of like time scale. All right, so what are we looking at? Same deal again. Kelvin wave generation area from here to here going straight up the chart. Here is our westerly anomalies. Now the future is up top, not at the bottom here. All right, so it looks like, just eyeballing this, it looks like westerly anomalies in the active phase of the MJO is fading. If I were to eyeball this, I'd say this is probably the inactive phase of the MJO, and then the active phase sets up again about January 2nd, continues the whole way through the end of the model run. Let's see how close we are. We're going to overlay the MJO. Hey, there we go. Oh, this even has the active phase of the MJO gone as of a couple days ago, and the inactive phase already setting up in the West Pacific. So you see all the models, they got a little bit different take on, a little bit of different shade of things. Some say, oh yeah, active phase still in control. Others say, no, the inactive phase is already there. Either way, it's coming. We know it's coming, and it's supposed to go on. Now, interesting, weak westerly anomalies, but a little bit of easterly anomalies. All this going on into about, I'll say about December 29th, something like that. Now, this is the interesting thing. Then the active phase comes, starting January 2nd, and it continues with solid westerly anomalies the whole way through, almost 2/3 of the way through February. If there was ever a big red X for swell generation, based on this model, based on the model going 2 months out in the future, this is probably it. So it looks like, as of right now, the rest of December is probably going to be a downtime in terms of swell production. But then, starting, we'll say late in the Christmas holiday, things are going to wake up and it's going to go gangbusters after that. And that would probably be indicative of when we get precipitation. In fact, when you see westerly, so here's the California coast. I'm looking for the presence of westerly anomalies over the coast. That's normally good for precipitation. So that actually says, yeah, maybe first 2 weeks of December we'll get some lingering deal. Look at this. You could probably almost put that red contour going out like this. It doesn't show, but I'd say rain into mid-December, then things back off, things dry up. There's your easterly anomalies. And then as you get into late January, the storm machine cranks up again for the Tahoe and Sierra. All right, what else? Oh, low-pass filter. Got to do this. All right, so this is the solid contour. It's like an area of low pressure. Not really, but it's a bias towards low pressure, sitting right over the date line. Yeah, this is the way it's been. 2 contours. Now, this was supposed to fade out about a month ago completely. The second contour was supposed to be gone by the time we got into like late January, February. Now this model says, hey, nope, it's going to hang on. We'll take that. And the dotted contour here, high pressure bias, locked in the Indian Ocean, going nowhere. Looks like this pattern is set up for the rest of winter. That's not too bad. I mean, I don't like this blocking thing going on in the Indian Ocean, but, if we can keep the low pressure bias over the date line, we'll eke out basically a normal year is my guess. All right, enough MJO discussion. Let's talk even longer term. What's going to happen over the next year or more? Okay, for clues, we start looking in the Pacific Ocean, not on the surface, not above it. We've all been talking atmospheric stuff. Now we're going to go dig into the ocean. This is the West Pacific here. This is the East Pacific here. This is the surface of the ocean. And these are the anchor lines on the TAA buoys, strung the whole way across the equator. What is it, 3,000 or 4,000 miles across the Pacific Ocean. The X's are the sensors on the anchors. You guys know the drill. The sensor data, along with a model, helps fill in the gaps. You get a profile of the sea surface temperatures. This is in centigrade. So 30 degrees centigrade water over in the West Pacific. That's pretty warm. Multiply that times 1.8 to get whatever your actual temperature is. Anyway, that's the 30 degree isotherm, the 29 degree isotherm, and what we're looking for is it moving east or west. It's actually retrograde. I think it was at the date line last week, or 179. Now it's back to 175 east. This guy was hovering at one point around 155 east, the 29 degree isotherm. It's pulled back to 171 degrees. The 28 degree isotherm line was over at 150 or something like that. It's back to 160. And the 24 degree isotherm was fully onshore last week. It was about 105. Now it's at 110. What's all this mean? Well, it means that warm water, which was pushing to the east, which could signal a Kelvin wave, appears to be backtracking a little bit. Okay, but let's dig deeper. It's the anomalies, differences from normal for this time of year. That's what really counts. Last week we had, so West Pacific here, East Pacific here. Warm anomalies here was at 2. It was 3, almost 4 last week. So a Kelvin wave, I think this is Kelvin wave number 5, pushing onshore right now. It's a weak Kelvin wave, but it's pushing onshore over Ecuador. Okay, that was generated by westerly anomalies, the active phase of the MJO 3 or 4 months ago. It takes that warm water here, starts pushing it to the east. That's why we're measuring these isotherm lines and seeing whether they're going east or west. But what it does is it pushes it not at the surface, but down at depth, somewhere down around here, and it works its way across like this, like a ball of warm water. This is a Kelvin wave moving onshore. Here is a new Kelvin wave. Now remember, we're still in what appears to be the active phase of the MJO. We've got westerly anomalies been blowing for a month and a half. Okay, it's taking warm water 3 degrees now, creating Kelvin wave number 6 in the West Pacific. This is, so typically you get a Kelvin wave, it'll move onshore, then you get a little cool ball of water that'll pop up behind it for a couple of weeks, and then boom, you'll get another warm burst behind it. Again, 3 to 4 months for this warm water to go from here over to here. So it's a very slow moving train. All right, another model of the same data, basically saying the same thing. There's your cool ball. Here, this is a little bit stronger. What is this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 4 degree pockets of anomalies here, but this model tends to run about a week behind, so that makes sense. Yeah, the Kelvin wave number 5 moving onshore, Kelvin wave number 6 developing over in the West Pacific. basically, we are in pretty good shape here. We'll scroll up. Oh, yeah, sea surface heights. We're always interested in that. So this is just another way to confirm what we were looking in the previous charts. This from Jason 3 satellite measures sea height anomalies, differences from normal. If the sea height, we're not talking waves, we're not talking wind swell, even take out the tides, but if there's a little bump on the ocean surface, this is a very, oh, here's the scale, 0 to 5 centimeters. 0 to 5 centimeter bump off Ecuador, suggesting so warm water at depth expands, creates a little bump on the ocean surface. That's what we have here. Okay, a little bit of warm water there, but here's our newly developing Kelvin wave number 6, and it's only 5 degrees north to 5 degrees south from the equator, but certainly more evidence that one Kelvin wave there, moving onshore, dissipating, new Kelvin wave building. We wouldn't have this if we were in La Nina. So at a minimum, we're in a ENSO neutral phase, not an El Nino, though. There's not enough other data to support El Nino. And here's kind of a historical look of what's going on, all right? So this is the West Pacific here, East Pacific here. You can see, let's see, if that was Kelvin wave 5, that's Kelvin wave number 3 back a year ago, making its way the whole way across the Pacific. It started somewhere probably back in October, November, moving onshore. Kelvin wave number 4 started from a westerly wind burst in the January time frame and made its way across the Pacific into Ecuador by May. That is 5 months. Then 2 Kelvin waves that stalled. They never went anywhere, and you just had this kind of, the upwell, the cool pool after the Kelvin wave scenario. Now here's where we are. We had a westerly wind burst in early September, created Kelvin wave number 5. It is moving onshore today. Here's the start of Kelvin wave number 6. So historically, you can watch these guys move across the Pacific. All right, why are they important? Well, if you have enough, so you have to have active phase of the MJO, with strong westerly anomalies lasting long enough to take warm water in the West Pacific here, start pushing it east. If you get enough successive Kelvin waves, notice these guys stalled out. But if you have enough of them back to back, warm water starts pooling up over here in the East Pacific, and then that starts, because it's warmer, it starts feeds evaporation. Evaporation changes the jet stream. The jet stream then, if it persists long enough, the jet stream changes the whole way around the planet, and that's how you get El Nino. And of course, El Nino is great for supporting storm development in the North Pacific Ocean, both in the summer and in the winter, and for pushing rainfall and snow into California. But we're not seeing El Nino. Though, today's image, so this is sea surface temperature anomalies, differences from normal for this time of year, look pretty good. I mean, this is the best we've seen it in months and months and months. You want warm water, and that's what this is showing in this area on the equator, 5 degrees north and south. There's Ecuador, there's Peru right there. If you have, we're in a good El Nino. At Christmas time, you'd have this big old triangle of reds. Sort of looks like that right now, but this is 1 day's worth of data. A week ago, it didn't look anywhere near this impressive, and the reason it looks this way is because Kelvin wave number 5 is, it looks like it's fading on the previous charts we saw, but what's happening is all that warm water is boiling up, erupting to the surface here, and trades they're not stronger than normal, but they're not weaker than normal either. But they're not blowing it out. They're not killing it. So we have a building warm pool in this area attributed to Kelvin wave number 5. And then we have piles of warm water back to the west. Let's go take a look at the trend. Here's the trend for the past 7 days, and what we actually see is cooling along the equator. Now, that doesn't take into account today's updates. This is a lagging indicator. It'll take about 3 days for this guy to catch up. But my guess is what you're going to start seeing is warming building all in this area as Kelvin wave number 5 starts erupting more vigorously, assuming it continues to do what it's doing this evening for the next 5 to 6 days. You'll see a warming pattern building here. In fact, we saw a lot of warming off of Peru, was it maybe 5 days ago or so? I mean, things were looking pretty good. It's kind of died for the moment, but we think this will all start warming. And it's only on the equator we're interested in the Pacific. There is New Guinea there, that whole stretch. But El Nino, the main region. So the Niño 1.2 region is like right here off of Peru. The official El Nino monitoring region, the Niño 3.4 region, from 120 west, 5 degrees north and south of the equator, out to 170. So right here. That's the official El Nino monitoring region. Then here's your Kelvin wave generation area over here. All right, let's continue. And here is the sea surface temperature anomaly image for this evening. You see, yeah, it's warming. Nothing dramatic. That last image we showed you is probably more current. This is November 30th. What's that? Oh, well, let's just go look. That is December 1st, right. So the expectation is a day from now, tomorrow's image, you'll start to see some warming building in this area right here, attributable again to that Kelvin wave erupting. Most of the warmth, though, is over here in the Kelvin wave generation area. You get westerly anomalies in there, then we have some fuel to build Kelvin waves. Actual sea surface temperatures in the Niño 1.2 region, this area right off Peru and Ecuador, 0.780 degrees above normal. And that's the first time it's been this warm in months and months. That's actually a good sign. Certainly no sign of El Nino. And anyway, this isn't the official El Nino monitoring region. Here it is right here. And you see today's value, 0.111, a tenth of a degree above normal. We were actually below normal. The trend had been significantly up. We've had a little hiccup the past 2 weeks, week and a half, something like that. Let's see, though, with the eruption of Kelvin wave number 5, we expect temperatures to start building. It would start right here, just like that in the Niño 1.2 region. Then over a month or so, it would migrate to the west into the Niño 3.4 region. So we'll see. But clearly, no real sign. What? El Nino? El Nino requires half a degree above normal for 5 consecutive months. We've had 4 days of readings in the past, 3 or 4 months, however long this is. So we're nowhere near El Nino. But the good news is we're above normal. We're not below normal. So we're not in La Nina. It looks like we're in neutral, biased warm. More on that in a minute. Continuing on with the El Nino La Nina thread. All right, another way of looking at what's going on in the atmosphere. The index that we use is the difference of pressure between Darwin, Australia, and Tahiti. If the index is negative, that means there's lower pressure over Tahiti, which is in the Pacific Ocean. Okay, and if it's negative for a little bit, that's like 20 or 30 days. That's the sign of the active phase of the MJO. But if it's lower than normal for 90 days and significantly lower, then maybe that's a sign of El Nino. Peak El Nino time, right around Christmas, say second, third week in December. Index today, positive 4.10. But you look here, we're going back in time. It's been negative steadily for a long time. But you saw, looking on the other charts, we've had westerly anomalies in the Kelvin wave generation area, the active phase of the MJO. No surprise. 30-day average, it reflects that. It takes some of the noise out. Today's value, minus 9.40. It's been in the minus 9 range for, since November 20th. But it's been consistently negative. All this says is, the active phase of the MJO probably occurred, peaked out a couple of days ago. That's what this data looks like. 90-day average, are we in El Nino? No. To the value, minus 8.74. It'd need to be down around minus 15 to be El Nino. So we're not La Nina, because there's no positive numbers to be found here, but we're not El Nino because we're not deep enough. All right, here's sort of the graph. You can sort of pick it out. But the 30-day average is this solid line trending downward, indicative of the active phase of the MJO. It peaked out right before Thanksgiving. Looks like it's going to slowly work its way up. The 90-day average, this is your the dotted line here. That is your El Nino indicator. Again, we need to be down at minus 15. We're down at minus 9 or 8 or whatever it is. And I'm sorry, 8. I see. We can actually get the reading. 8.74 and heading upwards slightly. So not El Nino, but certainly not La Nina. We'll take it. And then finally the forecast. The Niño 3.4 sea surface temperature anomaly forecast. And we're going out into next summer. All right, so where are we? We're in early December. Temperatures forecast at about 0.45 degrees above normal. That's a little bit on the high side. I think we're trying. But anyway, the forecast is basically temperatures hovering right about where we are for the rest of winter and into spring of next year, falling to just neutral in August of the coming summer. That's good. No sign of La Nina whatsoever. Again, we think we're in the warm phase of the PDO. It would not be, and the PDO is like an El Nino that runs for 15 to anywhere up 25 years, something like that. When in the warm phase, it basically is an environment more favorable for warm temperatures in the Niño 3.4 region. It is favorable for storm production in the North Pacific Ocean. It's sort of like a very weak push towards El Nino. And if you do get the warm phase of the PDO and a strong El Nino, and they all line up together with the active phase, the multiple active phases of the MJO, you can get some serious storm cycles like what happened in the winter of 97-98, also in the winter of 82-83. All right, so we think we moved into the warm phase of the PDO in 2014. We think we're still there, okay? This year, we would expect us to be neutral, but sea surface temperatures biased a little bit warm. Maybe that's global warming. We're not going to get into that discussion. Maybe it's the PDO. We'll go with that. PDO probably having a positive influence for this year and many years to come. So the quick synopsis, certainly plenty of weather for California. Storm production limited to the Gulf, Eastern Gulf, not favoring Hawaii so much, favoring California, but also with a lot of stormy weather. We expect this will go on for another, we'll say 2 weeks, and then the inactive phase of the MJO is going to set up. Things will settle down. The hope is that we build up a healthy snowpack, get all the resorts open, get some time on the mountain for everybody through the Christmas holidays. Maybe we'll get some storms even though we might be, or we're supposed to be in the inactive phase of the MJO. Take care of your Christmas shopping, take care of your family, enjoy your loved ones, and then as we get into maybe the second week of January, it looks like the storm door is going to open again, and we're going to be back in business. Swell-wise, maybe, or maybe it's just going to be a stormy mess, and then it'll be snow and rain. So take whatever you can get, but things looking pretty good. And long-term forecast, no El Nino in the cards, but the PDO keeping things interesting for maybe the next 15 years. All right, that's it for tonight. We'll do this again next week, same time, same channel. Also, if you enjoyed the video, give us a thumbs up, hit the like button. Also, subscribe. You can subscribe down there. Click the buttons, ring the bell, and when we update the forecast, you'll get an email. Otherwise, you can always visit stormsurf.com. All the material that's presented here tonight is available on that site. And that's it for tonight. Enjoy your week, and we'll see you next week.